Today we are going to explore about nanomaterials. Introduction.
Nanoparticles. Today we are going to explore about nanoparticles. Introduction. A nanoparticle or ultrafine particle is usually defined as a particle of matter that is between 1 and 100 nanoparticles in diameter. The term is sometimes used for larger particles up to 500 nanometer or fibers and tubes that are less than 100 nanometer in only two directions. At the lowest range, metal particles smaller than 1 nanometer are usually called atom clusters instead. Nanoparticles occur widely in nature and are objects of study in many sciences such as chemistry, physics, geology, and biology. Being at the transition between bulk particles and atomic or molecular structures, they often exhibit phenomena that are not observed at either scale. They are an important component of atmospheric pollution and key ingredients in many industrialized products such as paints, plastics, metals, ceramics, and magnetic products. The product of nanoparticles with specific properties is a branch of nanotechnology.
History of nanomaterial. The first uses of lead date back to 4000 BC, Egypt, and later it had several applications like piping during Roman Empire. As a matter of fact, lead was the favorite metal used in piping for a long time. However, its negative impact on human health made it necessary to replace it for pipes made out of other materials like polyvinyl chloride (PVC). Meanwhile, fiberglass has also been around for a very long time. However, it was first produced at an industrial scale during the 20th century. It was used initially as an isolating material, but its chemical strength, flexibility, and transparency, among other properties, made it possible for it to be used for different purposes. It is particularly important its use in optical fiber and how it replaced copper for enabling internet internet connection thanks to its fastest transmission rate.
Nanoscience and nanotechnology are the study and application of extremely small things and can be used across all the other science fields such as chemistry, biology, physics, material science, and engineering. It's hard to imagine just how small nanotechnology is. 1 nanometer is a billionth of a meter, or 10 raised to minus 9 of a meter. Here are a few illustrative examples. There are 2 crores 54 lakhs nanometers in an inch. A sheet of newspaper is about 1 lakh nanometers thick. On a comparative scale, if a marble were a nanometer, then 1 meter would be the size of the earth.
Okay, then we are moving to next slide. Nanoscale properties. First one, total energy of the system. In nanoparticles, the number of atoms, hence the length scale, is substantially different to that of bulk material, so the energy and energy separations of individual electronic states will be different. The main effect of these alternations change the total energy of the system to a most stable form. Second one, high specific surface area and energy. An atom is isolated nanoparticle. A large proton of the total number of atoms will represent at the free surface. So an atom is isolated in the surface and number of nearest neighboring atoms are reduced. Third property, optical property. That is, we are going to read about HOMO and LUMO. HOMO means highest occupied molecular orbital and LUMO is lowest unoccupied molecular orbital are modified in nanoparticles. Fourth one, color. Unexpected visible properties. Example, gold nanoparticles appear deep red to black in solution. Fifth property, magnetic properties. These are the properties of nanoscale properties.
Fullerenes. Fullerenes, also known as buckyballs, exist as C60, C70, etc. The canonical structure C60 has isocosahedral symmetry and an electronic structure similar to that of graphene. Fullerenes can be made in a carbon arc but bumping a hydrocarbon feedstock with strict control of the oxygen supply is a more controllable method. The fullerenes can be separated from co-produced soot amorphous carbon by dissolving them out, as you can see in the figure. The uses of nanomaterials are used in electronics, making magnetic data storage circuitry, and in biomedical, cancer therapy, MRI contrast agents, drug delivery systems, cell labeling, and in environmental, wastewater cleanup, environmental catalysts, fuel cell catalysts, biosensors, cosmetics, pigment, and is also used in making materials, pigment thermoplastics, coatings slash paints, and also used in transportations, like making brake systems, propellants, etc. And you can also see the application of nanomaterials in the next figure. The uses of nanomaterials, in the first image you can see the nanoparticle drug delivery in cancer therapy, and in the second image you can see it is used in the effective manufacture of propellants also.